right. Welcome everybody to this IEEE session for the AESS. We are very privileged today to have with us Mike Dinne, who has a lot of experience with the Australian space industry going back many decades. And Mike's going to talk to us today about his experience, some of his personal observations, and some of the really interesting things which you may not be aware of about Australia's involvement in the Apollo program as part of the ground segment activities for Apollo, and some of the insights that Mike's got into how all that worked and his experience in that space. So Mike, over to you.
Okay, thanks. Still coming through?
Yes, we can hear you.
Good, okay. I thought I'd just start off with a quick bio summary, which may or may not be of interest to people who are just graduating. I'll go through it quickly. If there's anything anybody wants to raise, we can talk a bit later on. I did a London engineering external degree in 1955, specialising in electronics. I then did a 2-year graduate apprenticeship with EMI. I'm not sure if such a thing exists these days, but it was great. 2 years of going all around EMI, which was Britain's biggest electronic company at that time. All the workshops of finance. I was involved in the very first digital computer that EMI was producing. I had the job of putting 8 bits of data on a 6-inch by 2-inch printed circuit board, each bit being 2 diodes and a capacitor. Things have changed a bit. So 2 years at EMI, and then another couple of years still with EMI, but drifted onto airborne radar, the radar for the V-bombers, H2S it was called, Mark 9, which gave me my first introduction to what you might call space-ish type electronics. I then moved back to my hometown of Bradford, English Electric, which made aircraft electrics, which was quite sophisticated. It was a 4-engine constant frequency system on board the V-bombers. So that was a different approach to aircraft type work. However, they were really pretty old-fashioned there. So I was looking around for a job move. I got a friend of mine had moved to America, so I started applying over there. I had an offer from Singer-Link on flight simulators, but they reneged on that. Then I saw an advert for a job in Australia, which we'd never even thought about. Anyway, I applied for it, and much to my amazing, I got an interview. Much to my amazement, I was offered the job, and then ran out of excuses not to come. So we came out by sea to Melbourne, and I was in charge of flight test instrumentation at the Aircraft Research Development Unit, Laverton. No longer a flying base. ARDU still exists. So it's at Edinburgh, South Australia. So I was lobbed into an Air Force organisation. I was responsible for a wing commander. I had about 4 or 5 staff, and it was a bit daunting. However, it was great. The Air Force had just selected the Mirage aircraft. My first boss was, forgot his name now. Anyway, he went on to be boss of the Air Force and governor of New South Wales. So I worked for a wing commander, sort of. There were a few of us civilians at RDU, especially others on performance and handling. Anyway, after 5 years there and visits to France and flight testing in Darwin, I looked around for another job and saw this one advertised at Honeysuckle Creek. I applied for the one at Honeysuckle Creek. At the interview, said, if you don't get that, would you like one at Tidbinbilla, which I'd never heard of, and I knew nothing about tracking stations. Anyway, I said, well, yeah. So we moved up to Canberra. I drove up on the 14th of February 1966. Whoever was it, not many of you would have been alive at that time. That was Decimal Currency Day. That's how it sticks in my memory. And so from 66 to 67, I had my first exposure to space tracking. And in that era, the policy was the deputy director was in charge of operations. And so I was lobbed into the middle of this facility, which already had about 130 people, and plonked onto the operations desk to run ops, which was a bit daunting. The first mission was the first American soft landing on the moon, Surveyor, which was amazingly successful. And as I've said semi-sarcastically in recent days, we, me being part of the total project, successfully soft landed a spacecraft on the moon, and it didn't fall over. And that was in 1966. Anyway, after 18 months, I was asked to move to Honeysuckle, which was great because that's what I originally applied for. I moved over there and had a similar job there, namely not responsible for operations. My friend John Saxon called himself operations manager, which I guess was the terminology then, but nevertheless, the deputy director was required to be the so-called Ops 1, and that's the job I had from Apollo 7 to 13. I then went back to Tidbinbilla while the big new dish was built at Tid, known as DSS 43, now extended to 70 meters. And by the way, it tracked Apollo 17. It was just about finished. I was at JPL on the system design for it, and I thought it could be finished in time for 17. Tom Reed, my boss at Tidbinbilla, agreed. JPL weren't at all keen on that, but anyway, the DSS 43, as it was known, tracked Apollo 17. So it's one of the few physical dishes that actually did track that mission. I then sort of did myself out of a job, had 10 years in defense on aircraft projects, looking for Australian participation in the avionic business. And at that era, the 70s, there were several quite large and very capable electronic companies in Australia, but they all seem to have disappeared as far as I can tell. I mean, AWA was probably the biggest, Plessey, EMI in South Australia, British Aircraft. And so I went around the world several times on defense projects looking for Australia participation, and in particular looking for the new maritime aircraft, the P3 Orion, and then later on for the new fighter. I went around the world for the new fighter mission twice, where we ended up selecting the F-18. Anyway, but this was a head office job with all the joys and frustrations that you can expect. The opportunity came up to get back to Tidbinbilla in 1983, and I was in fear and dread that my transfer, it was a level transfer, would not be agreed. So when I handed my white badge in at Campbell Park in Defence, I rushed away as quickly as possible to get back to Tidbinbilla. And then I spent the next 5 years as the deputy, in particular the Voyager 2 Uranus and Neptune encounters, and coordinating the park's efforts. Sorry, this is dragging out a bit longer than I thought. And then when Tom Reed retired, I was director for my last 5 years, 89 to 94, by which time I'd had a few medical problems and a few other things. So I retired in 94. So I'm now 30 years retired. I still don't have too many problems remembering back 50 and 60 years, but remembering back 3 weeks is a bit more of a challenge, and getting something like Teams working, for example. Anyway, some quick politics. The organization, certainly in my day, was a government-to-government agreement, and that at the working level was between NASA and what I originally was in, the old Department of Supply, which disappeared in the early 70s. But this is a pretty important modus operandi. My bosses, and right up to the head of Department of Supply, said the philosophy is tell to NASA, tell us what you want done, we'll do it. Don't tell us how to do it unless we ask. we'll tell you how much it cost, and you'll kindly pay the bill. That's the way we did business. Staffing, contracting, etc., will be an Australian responsibility. I have a feeling that's got watered down in recent years, but it was a great system to work under. So at the station, we had a director who was department supply, the deputy director, myself was op supervisor, staff was contractor, AWA, EMI, SDC. It was a cost plus award fee contract, which was novel for Australia, but it operated more or less okay. And there were many, many other Australian participants, CSIRO, ACT government, Postmaster General, Telstra, OTC, Civil Aviation, because they were tracking aircraft operating out of Australia, Department of Works for buildings, and they were tracking ships operating out of Australia as well. So I heard it said that the space business was the biggest customer of PMG in the 60s. All right, heading right along. This is just a quick look. I think it was during Apollo 11. This particular photo was taken of the dish at Honeysuckle Creek. The building is no longer there. The antenna is now physically at Tidbinbilla. If you ever have a ride out there, it's the first dish you come to. It was an XY mount. Generally, all tracking antennas are usually two axes, all with various compromises. Because unless you've got three axes, you can't really cover the whole hemisphere. Honeysuckles was XY, which meant and it was oriented in such a way that we couldn't track right down to the horizon in the east and west, which was really a bit stupid, whoever made that decision. So we had Honeysuckle as the XY dish. We had the station at Tidbinbilla, which was an R-angle declination mount, as you can see. Same size, mind you, but better low noise amplifiers, known as DSS-42 for deep space tracking, or HSK-X for the manned spaceflight tracking. And for some missions, we had Parkes, the Parkes dish, 210 feet, 64 meters. That's got to be a fairly early picture because the solid panels are very few in the center. If you look at it today, there are solid panels, more solid panels further out. So we had a microwave link that, by the way, shows you the relative location of Tidbinbilla vis-a-vis the central Canberra, the other side of the Molonglo. It used to take me 35 minutes from home to there, 33 minutes if I pushed it, and 37 minutes if I dawdled. Honeysuckle, you go via Tharwa and turn off a dedicated road, and Honeysuckle is about 300 meters higher than Canberra, and so it was one of the few places I've tromped through snow a couple of times out at Honeysuckle. So that was the Canberra arrangement. There was a microwave link joining the two with a passive repeater up what was called Dead Man's Hill on the microwave link. So here's the dish at Honeysuckle talking on the microwave link. That was the passive repeater on Dead Man's Hill, and this was the dish receiving at Tidbinbilla. We had a lot of Holden cars, as you can see, in those days. Initially, we used to have a fair number of car accidents. The roads weren't sealed, and of course, there were quite a lot of kangaroos. But we had one semi-serious accident, but it wasn't too bad. The original building at Tidbinbilla was for the deep space tracking. A special wing was added on at the left-hand end for all the manned flight equipment. So we had all sorts of links. Oh, we also had links into Red Hill, went via a repeater on Williamsdale, which is alongside the Cooma Road. So we needed a lot of cooperation from the PMG and the commercial things. How am I going? Is it coming through all right, Peter? Lily?
Yep, it's fine. It's good, John. Keep going.
Okay.
Sorry, Mike, keep calling you John.
No problem. I'll do a quick rundown of the station layout. Three sort of major areas. The antenna, which was up on a bit of a knoll, an operations admin building, and a powerhouse. There was no commercial power. It was all fed by diesel generators on American standards, 60 hertz, 115 volts. So that's the general layout of it. The main operation, this was the main operations building layout, which on this side of the building were offices and administration, a main storeroom, test equipment. But the four operational areas was what's called the unified S-band, which we call the front end. That was transmitters, receivers, and antenna control. There's the telemetry area, which took the data stream and formatted it for passing on to the computers, which is on this corner here. And the data went out through the communications room, which is over here. And we had this the comms was here. This particular room was a wire room. The amount of wiring just for intercoms and the like was incredible. And then finally was this operations area, which is the one I used to be physically in. So that's the unified S-band. There's the man driving the antenna. There was a staff of about 28 people on shift, by the way. And digressing slightly, people say, how did you do it without modern computers? I said, well, we had the best computers that there is, namely people with skills, education, competence, can operate, maintain, calibrate, repair, troubleshoot. Now, a bit expensive on having to have a lot of people, but nevertheless, very, very flexible. And we could cope with anomalous missions like, say, Apollo 13. This is all this line of racks on the left are 4 receivers and 2 transmitters. In the back middle is a ranging system that measured the distance to and from the spacecraft down to about 1 meter. And the racks on the right were precision timing and formatting the tracking data. The tracking data comprising the Doppler shift on the transmitted received frequency and the antenna pointing angles. So then in the telemetry area was decommutators for the data, lots of knobs, switches, and meters and people, and lots of recording, magnetic tape recording. And then the computer area, all those are of that vintage. This particular pair of racks, if is my mouse showing on there, Peter? Is it?
Yes, it is.
Okay. The thing I'm pointing to there, that was all of 32 kilobytes of storage, which of course you get on a fraction of a chip nowadays. So this was actually shipborne hardware, but it worked well. But when you look at the size and the space and the like, compared with today, it's ridiculous. The whole of those racks could probably, could be done in a PC nowadays. We had clocks around the place. The missions were generally run on what was called GET, ground elapsed time. That was time from launch. So the flight plan was usually written in GETs, but also, of course, we had to work in Greenwich, the common time, Greenwich Mean Time, GMT, or Zulu time for anybody who's ever been involved. You wouldn't imagine the number of problems we had reconciling times all around the world, but we did. Then there was the communications room. We had quite a number of circuits, but they were all carried on two pieces of copper that ran alongside the Tharwa Road. 12 channels of audio data. And every time I drove past, I really worried. But my main job as Ops 1, as we were called, was to worry about not a nominal mission, but abnominal. I had lots of spare backup, spare equipment, spare antenna. And so I had spare communication circuits to get into Canberra via Tippimilla. But and so I ran a simulation one time where we simulated lots of one of those pieces of copper on the road to Tharwa, and we lost all communications, and chaos reigned. First of all, you've got to get the comms people to agree there's a bloody outage. Then they've got to start to find out who to blame, and the famous phrase like "it's all right leaving us" became famous. Then someone has to coordinate the restoration. And it taught everybody a great lesson that it's one thing to have redundant, by the way, using that word redundant in the American way, i.e. spare equipment, but unless you know how to use it, you're not necessarily any better off. And then finally is the ops area. So that's me. What I would have been in my 30s then, and John Saxon. We had numerous intercom capabilities. We also had capabilities to talk to the spacecraft if we had to, which I did once on Apollo 8 and John did on Apollo 15. It was exceptional though, because all our up and down voice just went through the station, across the Pacific and into Houston. I got myself a lot of meters giving me the signal levels on all the different receivers and the like. And we described the communication, we described the configuration of the station on a board with elastic bands. And I had a television camera up on the wall here to let the station know what the configuration was. This gives you some idea of the communication circuits. They were all centered on the Goddard Space Flight Center in Maryland. So the various circuits concerned with Australia were trans-Pacific cables and satellite over usually to the west coast, onto Goddard, and then to Houston. It all worked surprisingly well, but as I said earlier, PMG and OTC were intimate partners in this whole operation. There was another switching center in London, and there was a tracking station at Johannesburg at one time. Our Carnarvon was another important. Carnarvon had one of the tracking stations. It had a 30-foot dish miner. It was there for near Earth tracking, whereas the Canberra, Madrid, and California stations were meant for lunar distance tracking. This is a recent picture of the Deakin Exchange on Kent Street, and this whole of this ground floor carried all the communication circuits into and out of Australia. There were redundant cables out from that building. Although one time there was a fire in a tunnel, and it turned out both those redundant cables were in the same damn tunnel, and so we lost all the comms for at one time. Okay, moving on to the missions. The first lunar landings was the unmanned Ranger, which was intentionally targeted to crash into the moon, taking pictures on the way in. It took JPL quite a while to get that to work. They missed the moon 2 or 3 times to start with, but eventually it was successful. Then there was Surveyor. This was the first missions I was involved with. First landing on the moon. And if you notice, compared with some of these recent attempts, a big wide foot pads and a low sense of gravity. and there was none of them ever tipped over. Whereas for some reason, today's designers seem to be working with small foot pads and high center of gravity, and there hasn't been any recent success in unmanned US landing. And then there was a thing called Lunar Orbiter, which took detailed pictures of Apollo landing places. The sister deep space station at Woomera was concerned with tracking Lunar Orbiter. Tidbinbilla was concerned with tracking Surveyor. In addition, of course, with the manned missions, the Mercury single astronaut, Alan Shepard, was the first one to fly that. John Glenn, of course, was the first successful orbiting person on Mercury. Then it was followed by Gemini, two people astronauts, durations up to a couple of weeks. So these are all pretty logical steps and happening fairly quickly. Then the first one, what we were concerned, the first Apollo mission with people on board. I'm not allowed to use the word manned anymore, so I stumble when I get to this sort of thing. They talk about crewed missions. So this is the first flight of the Apollo command module. The cone part, the front bit, is the command module. The bit behind is a service module where there were fuel cells, etc. And the two combined was known as the CSM, Command Service Module. And this is sort of partly relevant. This is the range of coverage we had out of Honeysuckle for the distant height orbits, as you can see. And this little kink east-west is because of that XY antenna mount. It was the most stupid place. The Carnarvon station had what they call them keyholes for some obscure reason. Carnarvon had theirs north-south. It would have made far more sense for us to have been north-south. Anyway, we coped. Apollo 8 was the first manned mission, Borman, Lovell, and Anders. This was only 2 months after Apollo 7. During Apollo 7, I was asked if I thought the station could support this was in about October, whether the station could support a lunar mission before Christmas. And I said, well, yeah, I think it can. So I guess my input and everybody else's input, went ahead to the next flight should have been testing the lunar module, but it was late. So Apollo 8 went to the moon over Christmas, 1968. I got to talk to Apollo 8 on the way out. We lost the link between Houston and the spacecraft broke somewhere, and Houston called me and said talk to the spacecraft, which I did. Here's a recording of it, but you don't hear me. You just hear Borman answering. Now let's see if this works. So Apollo 9 was a checkout of the lunar module in Earth orbit. Really gutsy. The people climbed out of the command module into the lunar module, and they separated, and I think they're about 80 miles apart from each other. And the life of these two people in the lunar module was dependent on them being able to get back to the command module, dock with it, and then climb through the tunnel. So although it never makes the news, it really was an impressive mission. It was only 2 months after Apollo 8, by the way. So we had Apollo 7 and Apollo 8 and Apollo 9 at 2-month intervals. Then Apollo 10 with astronaut John Young on board, Stafford, Gene Cernan, and it did everything except land. There's been mutters that they could have landed if they'd chosen, but I've heard it said that was impossible. They didn't have enough fuel on the lunar module. So that was 10. Then we came to 11. We were prime. We weren't tracking for the landing as such. It was about 6 a.m. in the morning, our time. The moon didn't rise till about 11 a.m. thereabouts. And we've got a really good video here now. If Lily, you can work out a way of playing this video. Do you think you can?
So first I can play that.
Oh,
You
yes.
hear?
Yes.
This isn't very long. Just let it roll.
Well, like they load y'all in Australia. How's everything down there?
And I was saying, how's everything up there? Very inane.
Pretty good so far.
So, I realized quite recently that I had the world's long distance comms record for a few minutes there. Anyway, go through Lily, 1 or 2.
Not stop, sorry.
No,
It is
just
stopped.
click for the next slide.
Well, like they load y'all in Australia. How's everything down there? Pretty
Right.
good so far.
Okay, next slide.
Thank you.
Next slide, okay.
And next again. Next again. Now. Have you got audio?
Yeah, can you hear that?
No. This runs 3 or 4 minutes.
This
The best
diagram
summary
shows the Earth as
of how
seen from the
television
Moon
was handled.
at the beginning of the Apollo 11 moonwalk. When the EVA began, 3 stations were tracking the lunar module at Tranquility Base. The Goldstone Apollo station in California was using the large 64-meter deep space antenna. Goldstone was the prime station for the lunar module throughout the moonwalk for both uplink and downlink. Voice and telemetry were sent from Goldstone to the Goddard Space Flight Center in Maryland and then on to Houston. Goldstone's television was sent direct to Houston. While the date was Sunday, July 20th in the US, in Australia it was the afternoon of Monday, July 21st. 2 Australian stations were waiting for the television camera to be turned on. First, the Honeysuckle Creek Apollo station outside Canberra was using its 26-metre antenna to receive signals from Tranquility Base. It was also handling the uplink and downlink for the command module, Columbia, through its wing station at nearby Tidbinbilla. Second, 300 kilometres to the northwest, the 64-metre dish of the Parkes Radio Telescope had been brought in as an auxiliary station to Honeysuckle. Parkes was capable of receiving but could not transmit to the spacecraft. The voice and telemetry received at Parkes was sent to Honeysuckle, where the best from the 2 stations was then sent on to Houston. Television from both Honeysuckle and Parkes was sent direct to Sydney, where NASA controller Charlie Goodman, seen at left, selected the best of the 2 for satellite transmission to Houston. As the lunar surface camera is turned on, both Goldstone and Honeysuckle Creek begin receiving video.
And we're getting a picture on the TV. Honeysuckle video online.
That was my call there.
An incorrect switch setting at Goldstone means their picture is upside down for the first 30 seconds.
Goldstone video, Houston TV. Goldstone video, go ahead. Can you confirm that your reverse switch is in the proper position for the camera being upside down? Verify the position. We will go to the reverse opening I ought to have on the camera. We are in reverse. All right, thank you.
Once that is corrected, it becomes apparent that the picture being sent to Houston from Goldstone is very dark. Viewers can just make out the silhouette of Armstrong's boots and legs as he descends the ladder.
Okay, Neil, we can see you coming down the ladder now. Okay, Neil, we can see you coming.
1
The picture being received at Goldstone is excellent, as is suggested by this still photo. The problem seems to lie in the settings for the conversion equipment that sends the picture onto Houston.
Okay, I just checked, getting back up to that first step.
Meanwhile, in Australia, at Honeysuckle Creek, with its smaller antenna, a good picture is being seen. Using his handheld Super 8 movie camera, Honeysuckle's video tech Ed von Renwaard records Neil Armstrong coming down the ladder.
Okay, Neil, we can see you coming down the ladder now.
A momentary flaring is seen as Ed attempts to brighten the TV picture. Armstrong checks getting back up the ladder.
Okay, I just checked, getting back up to that first step.
Days before the moonwalk, a decision was made to allow Australian TV viewers to see television direct from Honeysuckle and Parkes via the Sydney Video Centre. About 5 seconds after Ed's unofficial Super 8 film begins, the Australian network switched from Goldstone's picture to the local picture coming from Honeysuckle Creek.
Okay, Neil, we can see you coming down the ladder now.
This recording from the Australian Broadcasting Commission probably has never been seen outside Australia until now.
Too far, but it's adequate to get back up. Roger, we copy. Pretty good little jump. Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera. Okay. At the foot of the ladder, the limb footbeds are only depressed in the surface about
55 seconds after Australian TV switches to the picture from Honeysuckle, Houston also selects Honeysuckle's video for the international broadcast just before the first step.
The limb footbeds are only depressed in the surface about 1 or 2 inches.
All stations, we have to switch video to Honeysuckle.
Very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
At the start of television, the moon is too low in the sky for Parkes to receive stable telemetry and TV. However, as the signal improves over the next few minutes, Charlie Goodman at Sydney Video announces that he has a good picture from Parkes 9 minutes into the broadcast.
Roger, Parkes mine in the day 4 p.m. Well, receiver 1. Broadcast 1. Sydney Video, Houston TV, or Houston TV, Sydney Video.
This Houston TV, go ahead.
Please be advised I have a very good picture from Parkes. Shall I give it to you?
Roger.
Do you have it?
Roger, beautiful picture. Thank you.
Some of my first pictures here.
All stations, we're switching to Parkes at this time.
That's fine. We're going tape chain, going manual for a minute. Thanks.
Roger, Neil, we're reading you loud and clear. Let's see, get some pictures and the contingency sample.
Viewers worldwide stay with the Parkes picture until the end of the moonwalk. However, at Honeysuckle Creek, Ed von Renwaard continues to record unique segments with surprisingly good quality, some of which is better than NASA's official archive. This includes his footage 2.5 hours after the moonwalk finishes, of the astronauts' backpacks being dumped down the ladder. Ed's film seems to be the only surviving record of that event.
Okay, Lily, just hold it there a moment. Maybe we can stay with you for the last 2 or 3 slides. Would that be all right?
Yep.
Okay. I think you all have all picked up from that the TV of the first step was not as displayed in the movie, the dish from Parkes. It was from Honeysuckle. The Parkes dish sent the TV from about 8 minutes later. And by the way, the reason for this wasn't quite clear on there. The Parkes dish cannot go below 30 degrees elevation, and the moon was below that at the time all this was happening. Anyway, that this particular all right, we've got a next slide, Lily. This is just showing the degradation in picture happened during the scan conversion. It was coming down at 10 frames per second, and I think it was 320 lines per frame. And it was scan converted to the American NTSC by putting that display up on a cathode ray tube and pointing a camera at it. And the degradation was incredible. So that is showing you what the picture was like before the damn thing was converted. There was an attempt to find the tapes that this had been recorded on prior to conversion. A lot of effort went into it. Never been able to find the tapes. So there you go. That's what it looked like on our displays, but got hopelessly degraded when it got out of the station and around the world. Next slide, please. Oh, this is another bit of video. Just
receiver 1, put in Parkes name. D1 4 p.m. I get Parkes line in the D1 4 p.m. Well, receiver 1. Broadcast 1. Sydney Video, Houston TV, or Houston TV, Sydney Video.
This Houston TV, go ahead.
We should be advised I have a very good picture from Parkes. Shall I give it to you?
Roger.
Do you have it?
Roger, beautiful picture. Thank you.
I'll
All
show
stations
you.
are switching to Parkes at this time.
That's fine.
Wait.
Going tape chain, going manual for a minute. Thanks.
Roger, Neil, we're reading you.
Besides Delta and Alpha.
Let's see,
Besides,
pictures.
what does that look like?
Contingency sample.
Stand by. Honeysuckle network. Network. Honeysuckle.
Right, you might pass on to the Parkes people. If their labor was not in vain, they've given us the best TV yet.
Roger, thank you very much. We'll appreciate that. We'll monitor.
So there we go. I had discussions for 20 plus years with my friends at Parkes about where the bloody television came from. But in the end, I did get John Bolton, the director of Parkes, to agree. We agreed on the words that said, TV of the first step was from Honeysuckle, but majority of the best TV was from Parkes. But that gets lost in the noise when they make the movie The Dish. Okay, next slide, please. 13, I could spend an hour on this, but there's no point. The side of the service module was blown out by an explosion in an oxygen tank, and we really had to work hard for this mission. There was no book written for the lunar module to be used as a lifeboat, but through dint of effort and having 28 people on a shift who all knew what to do and get the best out of their equipment, Apollo 13 was saved. The movie, by the way, is quite good. It's over dramatized here and there, but it's well worth watching. And when the fella playing Jim Lovell, the well-known American actor, greets the admiral on the ship, that's Jim Lovell. himself in the movie. Okay, next one, please. Apollo, I'm skimming through 14, 15, 16, mainly because I wasn't directly involved. Apollo 17 and some of the earlier ones were far, far more sophisticated. There was a whole moon buggy marvelously packaged into the lunar module, had its own complete comm system, as you can see, but it was a highly successful mission. And as I said before, the big dish at Tibimbilla, that was its first mission. Next slide, thanks. All of this and more is in a website, honeysucklecreek.net. It's run by a fellow called Cole McKellar, who was a retired ex-Anglican minister, but he is by far the most skillful and most dedicated first nerd in Australia. It was him who rang me just a moment ago. He rings me every evening, and we chat about space. So I can thoroughly recommend that site for anybody. Next one, please. Oh, we got two moon. We got a moon rock. We got a moon sliver presented by Vice President Agnew via Tom Stafford to John Gorton in 1970. I had that on display at the visitor centre at Tidbinbilla until a few years ago, but someone decided it was too valuable to leave on display, so it's gone back into a filing cabinet somewhere in Canberra. No idea where. Next one. But I did succeed in getting a genuine piece of Apollo 11 moon rock. It's about 400 grams. It's on permanent display at Tidbinbilla. The visitor centre seems to be open at weekends now for Canberra people. Who knows what its value is? There was a moon rock came back on Apollo 15, was broken up into bits and distributed all around the world. And one of them was stolen. It ended up in a court case somewhere in America, and a judge decided it was worth $1 million a gram. So that piece of moon rock there on that basis is probably worth about $500 million. On the other hand, someone once said, take the total cost of the Apollo program and divide it by the kilograms of moon rock, and I think you come out like something like $10 million a gram. Anyway, there you go. Next slide. Oh, why can't we get back to the moon? Here's my theory. I click on the, just, there's me and John again. And you see, we've got a big ashtray there. Big ashtray. We all smoked then. So we all smoked and we went to the moon and back successfully. Now nobody smokes and we haven't been back to the moon. So there's your obvious correlation. There you go. Okay, next one. I think that's almost it. Yeah, okay. All right, that's it. Stop sharing now, I think, and just put it back to video.
Okay, all right. Thank you, John. Sorry, thank you, Mike. I keep calling you John. So thank you, Mike, for that excellent thing. What I'd ask people now is we have a question. Yeah, if we have a few questions, if you can raise your hand, I'll recognise you, and you can then speak. So please raise your hand if you have any questions.
Let me check the chat box. Is there anything there? Okay. I put several in the chat box. I found that there's there's in total like 17 missions from 1 to 17. Mm-hmm. Wow. That's a lot of series. Like I have the feeling that a great success actually is accumulation of a series of missions.
Yes. It was a very logically sequenced growth, upset, of course, along the way by the disastrous fire on Apollo 1, and that put in, apart from the human disaster, that put in over a year's delay. But when we reached Apollo 7 and onwards, we had missions at 2-month intervals. Mm-hmm. Now it seems NASA can't even do 2 yearly intervals. And I wouldn't like to be an astronaut when there's such delays involved, because on those 2 month missions, although it was hectic, we built from one experience onto the next and onto the next and onto the next. And I have a simple view. If anybody asks my opinion from America, I would tend to say, if you can't afford to do it properly, don't do it at all. And to me, all that seems to be happening, frankly, is a sort of a not half-hearted, but quarter-funded attempts to even get back to the moon. And all this discussion about getting to Mars in the decade, to me, is just a joke. Oh, and one of the jokes of that is these pictures of a SpaceX lander, a tall, skinny thing on little tiny feet, landing on a beautifully flat moon, which I think is absolutely. When I first saw it, I thought it was a cartoon, but it seems it's a serious suggestion. I hope it isn't.
So, Mike, that leads nicely into the question which has been asked in the chat by Joshua. He says, "Hi, Mike, what are your thoughts with the SpaceX program and how they are approaching space operations?"
Well, there you go. You sort of got a quick summary there. I have nothing against SpaceX. In fact, they've done some magnificent things. If anybody had ever said you could land a booster on a boat out on the Atlantic, I'd have said you're joking. Or you could bring a booster back and catch it between two girders. I'd say ridiculous. Well, both of those are achieved, which is astounding. But their philosophy appears to be push on, put up with failures and learn from them and keep moving forward. And there's something to be said for that attitude, but I have an instinct that says I think they are pushing that too hard. And or there's not enough funding to I want to guarantee success. There's also no doubt a low tolerance of failure for manned missions or crewed missions now than there probably was during Apollo. I mean, Apollo really was quite hazardous. And it is said that President Nixon sort of called a halt. There were still at least two sets of full Apollo hardware because he was afraid there would be a disaster on his watch. Anybody else's judgment is as good as mine. I'm not privy to any special knowledge. I'm 30 years out of date from a first-hand point of view. But that's what I think.
Okay. All right. Thanks, Mike. I'd like to recognise Adrian now. If you can open up your microphone and ask a question.
Yes, thank you. Thank you very much, Mike. That was really interesting. Question about the communications. Excuse me. What did the actual Apollo devices use for their communication, and was it analog communication or digital?
Well, both. We had what was, you may have noticed, the front end equipment was called the Unified S-band. I'm not sure why S comes into it, 2.2 gigahertz. And the principle was a single carrier with subcarriers. And so there was a subcarrier at 1.024 megahertz for telemetry. And telemetry, so-called high bit rate, got as high as 51.2 kilobits. So that was the high bit rate coming down from both the lunar module or the command module. And voice came down on a 1.2 megahertz subcarrier, phase modulated. Well, and those subcarriers were phase modulated onto the carrier. So this Apollo was quite different to Gemini, Mercury. They used more or less ordinary aircraft, air traffic type communications. But the Apollo system was, by the way, adapted from the JPL, Jet Propulsion Labs Pasadena. They pioneered this concept of S-band tracking. And by the way, the term tracking is a bit misleading. Communications. But from a navigation point of view, it relied on a coherent transponder on board the spacecraft. In other words, you transmitted up at one frequency, and it locked up on a phase lock loop in the spacecraft. That was then multiplied by 240 over 221, and I've never understood why that ratio was chosen. But anyway, and then retransmitted back to the ground, where on the ground we could extract the Doppler shift to a great, it was phase locked as received at the ground, and so the Doppler parameter could be extracted from the communications. And then in addition, there was a ranging capability using pseudo random noise codes, which I am told was a sort of a predecessor to GPS. It is supposedly one of the few things you can directly track back to the technology developments that's occurring through all of this. So that roughly in a nutshell, so telemetry was on its subcarrier, voice on a subcarrier, or we had a lot of biomedical data coming back. Each astronaut had a pulse rate and volume and the like. That data came back. And of course, television had to be squeezed in, and that's one reason it was on the first mission, it was such a small frame rate and light rate. Does that help?
Yeah, thanks, Mike. I'd like to now recognise Ed. Ed, can you ask a question?
Yeah, hi, Mike. Good to see you again. Great presentation. I really enjoyed it.
Yeah, Ed is a successor of me. That's it, among other things, many other things.
There was in 2016 we had a visit from Eugene Cernan to the station, and you came along to that. And there's a wonderful picture of you and Gene and us there. So I don't know if you've got a copy of that, but if you don't, let me know and we'll get you one.
If you look at my Facebook entry photo or whatever, there's you, me, and him, and a couple more. I think that may be the photo you're referring to.
Yeah, I think we had Hamish in there as well, but
yes, I'm pretty sure.
A few of us. But here's my question, Mike. Here's my question. Yep. If someone gave you the opportunity to be the director again at Tidbinbilla tomorrow, would you take it?
That's well, it's a bit academic in many points of view. I thoroughly enjoyed my time in my era, but my era was still largely knobs, meters, scopes, and operators, and so there was a continual challenge and continual evolution. But as things settled down, and they happened more or less in your era, I think, to a mostly digital system, reliant on the software that some smart person wrote somewhere, which anticipated every eventuality, things became fairly routine. Also, there were continuous budget pressures coming along. During Apollo, we had no budget pressures. So if I was asked nicely, I might, but I am getting a little past it at 60 years on, age 92 now.
Well, delighted to catch up with you, Mike. Thanks very much.
And you, Ed.
Thanks, Ed. We have a couple more questions in the chat, so just asking for people's indulgence while we take a few more minutes here. So Alicia has a comment in the chat.
Peter, the first one is the Katie.
Sorry.
Katie's question. What advice do you have for future Australian involvement in lunar missions? So what advice? Yeah.
I'm no expert on that. In fact, Ed would be closer to this than me. As I've heard it will still mostly be radio communications. There are developments in lasers, and I'm sure in the fullness of time, lasers will have a larger role to play. But I'd be surprised, and also some form of orbiting communication facility as opposed to a ground station. These are all possibilities which I'm sure someone somewhere is looking at, but the capabilities at Tidbinbilla are multi-million dollars, tens of millions, I suppose, and I can't see them being superseded for a while. And in fact, I think I asked Ed or someone in this century, what redundancy are you looking for the manned missions to the moon? And they said, oh, well, we've got tipping bill and 2 dishes. I said, yeah, but we intentionally had geographically diverse capabilities for Apollo, which were needed at one time. And to me, there's a hell of a difference between an unmanned scientific mission on the one hand and a manned/laded mission on the other. You've got to have different levels of thinking, redundancy and backup and alternates. And I'm not sure that NASA and everybody involved, maybe I'm overstating it, but I don't think I am. But I'm not convinced that NASA can see it, or it thinks it can't afford it anymore. But if they can't afford the redundancy for safety's sake, they really need to stand back and think, until the Chinese land, I suspect there's not enough political push going to occur within the US to fund all this properly. That I'd be interested in Ed's comment, mind you, on that last.
Peter, that's next is Alicia question.
So the next question is from Alicia. She's sorry she doesn't have audio. Thank you so much for your time, Mike. I was wondering what your thoughts are concerning the upcoming Artemis mission and Australia's role complementing deep space networks and international efforts.
Well, again, as I say, I'm not first hand on this anymore. I'm second, third hand. I sort of despair. I think the pace that appears to be occurring is not safe for a start. Not safe. If you can't afford to do it properly, you really shouldn't be doing it. However, the next Artemis mission is due to do a lunar orbit, or go out to the moon and come back, which won't be that different from Apollo 8. And so a landing on the moon still seems years away, and certainly is at the pace that things are moving at the moment. And the other impact I feel these delays have, who would latch their career onto these projects? It was great during Apollo. Everybody who wanted could get in on the project and see a vibrant mission going, contribute to it, influence it. But the pace of Artemis is just too slow from several points of view, but understandable. I'm not blaming anybody, but there has to be some political motive, and the only one I can think of is the Chinese landing sometime soon. That's all.
Okay, thanks, Mike. The next question is from Shri. So thank you very much for your time, Mike. You mentioned the NASA methodology, under which boiled down to give us your requirements and we'll tell you how much it cost. Do you see any return to that style of thinking with modern spaceflight? We seem to be going the other way entirely.
Well, I do agree with that last comment. I really don't know how that philosophy was put in place to start with in the 60s. There were certainly some strong-minded people at the top of the old Department of Supply. There was a particular deputy secretary called Lloyd Bott, who, by the way, had a fascinating World War II career, driving patrol boats across the English Channel. But a very pleasant fellow, got to know everybody at all levels at NASA. And the concept of Australian sovereignty, even though I still talk with my Yorkshire accent, was at the top of the list. And we had to politely, anybody who was involved, had to politely remind our NASA JPL friends that more often than not, we knew better than they did on how to run a bloody tracking station. But we had to do that very, very politely, and had to do it fairly often. But I think the pendulum has swung the other direction. When I was there, we did nothing classified at TID. And I used to truly be able to say, we only have a fence to keep the kangaroos out, which it actually didn't. But nowadays, the big fence and the like, and the multi-guards and everybody has a badge. I had to get a badge the other day to go from the entry gate to the back of the visitor centre. So I don't know. I'm glad you picked up on this point. It was an important point. It was an important point during the 60s, 70s, and 80s, and I don't really know. I've never seen CSIRO as the best match, frankly, for running tracking stations. But that I'm biased there. That's all.
Okay, thanks, Mike. One last question, a technical question from James. When you measure range from the ground in meters, what is the 0/reference point on the ground from which distance is measured?
The appropriate geoid, isn't that the magic word? I don't know the details. I don't know. The whole question of navigating is, I won't say closed book to me, but I never had cause or need to get into the depths of the detail that question is getting at. We had the best time standards in the world, probably still do, at the station. They were the only piece of electronics that had a standby power. We daren't lose the time standard, and the time standards lived in their own air-conditioned rooms. So there was great precision in time, and of course in California, they've been able to measure plate movements and California movements through the precision of the location of the stations. But as regards to detail, I'd just have to refer the person to Google.
Okay, all right. Thank you, Mike. So we're out of questions and we're well over time. So I'd like to thank everyone for their patience and staying a bit longer. Mike, I'd like to thank you on behalf of IEEE and on behalf of UNSW. This has been an excellent talk. I think everyone got a lot out of it, and it's great to look back and just realise how involved Australia has been in the space industry for quite some time. So thank you a lot.
Well, thank you. As you probably gather, I enjoy doing this, but I hate fighting Teams and PowerPoint.
Well, Michael definitely is a key figure in Australian space heritage. And I heard your name from Ed many times. I'm so lucky, like Peter, find you, and including John. He gave us a seminar in semester, which I put the recording of the link. First, I put a link in the YouTube. It's unlisted, but then John said, we want to make it public. So my question for you, Mike, today we record that. Do you want me to make it public in YouTube so that you're happy to say that? Okay, will do.
That I might say, well, after my 10 years in defence, Department of Defence, one of the greatest things of going back to Tidbinbilla was being able to breathe again and talk about what I did. There was nothing classified. Okay.
Okay, great. All right. Thank you, everybody. We might call that an end. Thank you.
Thank you, Mike.
Bye.
Really appreciate your talk.
See you.
Thank you very much.